All right, I've had a question about lesson number 5, part 2, or the second half of the homework. Question number 5. Airplane's headed north with a constant velocity of 450. So I'm going to give myself a picture here. So if that's my north, so there's my plane, 450 kilometers an hour. The plane encounters a west wind. Now the west wind means it's coming out of the west, so it's actually the wind is pushing the plane toward the east. It's just the kind of the language that we use. All right, so there's my vector diagram. So parts A and B are really talking about the resultant itself. All right, so we need to find the resulting velocity. I can anticipate it's going to be in this quadrant somewhere. So we can do the quick addition here. So we take our plane vector, which is 0I component, it's heading straight north, plus 450J. The wind vector would be 100I plus 0J. Adding that up, that would get our resultant. So we'd have 100I plus 450J. So we want to know the actual speed of the plane. So the resultant would be square root of 100 squared plus the 450 squared. And we'd end up with a value of 100 squared plus 450 squared. 460, let's call it 1 kilometers an hour. To get its direction, which is B part here, it's your y component over your x component. So tan theta equals the 450 over 100. Theta would equal 450 divided by 100, which you didn't really need to calculate, 77.5 degrees. So for A part, how far will the plane travel in 3 hours? So the distance of the, I don't know what that symbol was. There we go. The distance of the plane, it's velocity times time, 461 kilometers per hour over 3 hours. 461 times your 3. So it's going to travel 1,383 kilometers approximately. And B part, what's the direction? My x component was a positive, so the plane will be heading east at 77.5 degrees, and y component was positive, so it's heading north. All right. If you were hoping you want to do it geometrically, let's cut the triangle up for you. So geometrically, we need to create our triangle. So we know the plane was heading north, so we have 450. The wind is pointing this direction at 100. So we can find the resultant of our plane. And the nice thing is this is a right angle triangle. So you don't even need to use sine law. You can go ahead and use SOHCAHTOA. And then this is the angle you'd be interested in. And I can tell you right now, if you were to do it geometrically, if that was your choice, you'll get the exact same magnitude, 461. That theta that you calculate will be 12.5 degrees. So your answer would show up as you're heading north, then you rotate 12.5 degrees, and then you're turning toward the east. And that is also an acceptable answer from the geometric method. All right, so if you have any questions with that, let me know. You only need to pick one method. I'll tell you, algebraic will work every time. And because you're just setting the vectors up with their tails at the origin, it's a lot easier because a lot of people struggle with creating this closed triangle. All right, that seems to be always the challenge. So anyway, hopefully that answers your questions. If you have any other ones, let me know and I'll try to clarify them.